So this is the first printout of notes. Oh, I wanted to go over these really quick. Not to the point of like writing them down, but just literally going over them really quick. The very first one, mu stands for what? Mean of the population or population mean. The one below that, which usually has a little bit more of a squiggly part to it, is what? Population standard deviation. The next one down, lowercase n, is what? Sample size, capital N. Population size, lowercase s. Sample standard deviation, x bar. Sample mean, p. Population proportion, because hat means predicted. So p hat is sample proportion. Making sure you understand this, what is mu of p hat? Mean of the sampling distribution of proportions. So the next one is standard deviation of the sampling distribution of proportions. Why am I going over this again? Because you're probably going to have a quiz this week. So expect one day that you walk in, me just hand you this, take about 2 minutes, and then be done with it. So actual notes in front of you. Maybe, maybe not. Some of you would know this. The writing down what the sampling distribution of x bar is should be really easy if you remember what the sampling distribution of p hat is. And what is the sampling distribution of p hat? The fact that people don't know worries me a little bit. The distribution of what? So relating to the wall over there, the blue chart, it is a distribution, very generally, of all the dots from all the samples that there possibly could have been. So relating that, this is the distribution I want to write it the exact same way, of all values so each one of those dots for a sampling distribution of x bar is going to be a what? A mean. So distribution of all values of the means I'm going to say mean context. That's kind of a weird one to write. For proportions, I wrote proportion of population that were success, but mean's just going to be written a little bit differently than that. So it's the distribution of all values of the mean, however it is in context, from, and you said what? So I keep referring to GPAs of JOMAN seniors. If we were randomly selecting 20 seniors at a time and getting means of those seniors, this would be the distribution of all values of the mean GPA from all possible samples of 20 JOMAN seniors. So the mean of the sampling distribution, kind of tying back to this, what's the symbol going to be? What is the mean of the sampling distribution of x bar going to look like? Mu of x bar. Well, when I wrote this equation, for the quiz, I would write mu of p hat equals what? Because this is my parameter. So this is going to be mu of x bar equals what? Because that's my, this is talking about mean. This is my population mean. And I'm just going to write equals number. Now, one that we have not talked about yet is standard deviation. Sigma of p hat is square root of what? Which is kind of like binomial where it was n times p times 1 minus p. It's also got the square root of n on the bottom to account for like the error and the group. What's the only thing we deal with that is a standard? So like with proportion, we find standard deviation from proportion. With standard deviation, we don't find standard deviation from anything. We just have standard deviation. This one was finding the standard deviation of p hats from the parameter p. Well, this one we're dealing with, so this is going to be sigma of what? We have to find it from the population standard deviation, which is sigma, and it's still divided by square root n, which is the same accounting for error, accounting for sample size concept. For right now, yes. Which again, a lot of where we start here is like, why in the world would it actually give me that? And I would want to know this, which is how you should be thinking. But this is where we start. I still have a lot of my sheets set up for quizzing because I wasn't sure who in my next class is going to quiz at the same time and they don't have anywhere to go. If it's like blocking where you need to see and you want to take it down, I'm cool with it. If you want to pull out your Chromebook and go to Google Meet so you can see this better from your seat, I'm cool with it. But I think some of you aren't as bad as I thought y'all would be. All right, so then you would actually plug in numbers if you want to write equals numbers there. But so yes, as of right now, it's going to actually give us the population standard deviation. This is just a quick read through. Well, the sample mean x bar is unbiased if it's the same as the mean, which is what we're writing right here. The values of x bar are less spread out for larger samples. We talked about that before. More specifically, a sample 4 times as large cuts the standard deviation what? In half. Or it might be in half is how it was written, but as far as being able to look at it and see, it might be easier to just do that. I don't care which way you write it. A sample 9 times as large would cut it 1/3. That was what we talked about changing your sample size and how it affects your standard deviation, going through that whole algebra aspect. And then just a reminder, still the same, use the standard deviation. When's the only time we can use the standard deviation formula? 10% condition. So let's think about the way it wrote it. When the population is blank as large as the sample. At least 10 times as large as the sample. And if you're not going to remember that and you would rather just write this below it and be okay with it, that's fine. So 10% condition is still the case when we're dealing with means. Or it's still necessary to use standard deviation when we deal with means. All right, making sure we get concept here. Basic graph. I've got different dots up there. All my dots are between 1 and 9. If I randomly select a dot, what's the lowest value that I could get? 1. What's the highest value I could get? 9. All right, so let's pretend I'm dealing with the exact same distribution. and now I am randomly selecting 3, the value that I take is just the mean from those 3. What is the lowest mean I could possibly have? What are the 3 lowest numbers I can have? 1, 3, and 4. So what do I do with those? So it ends up being about here. 8 divided by 3. So 8 over 3, what is the highest value I could possibly get? You should be able to look at that one and tell. 8, because my highest possible numbers are 7, 8, 9. What's the middle of 7, 8, 9, 8? So when I switch it from dealing with individual values to dealing with means, what happens to my distribution? It's less what? It shrinks. It's less spread out. Do you see why that concept is? And all I'm dealing with there is the extremes. So that should make sense why, if I go from dealing with individuals to just dealing with means of individuals, my standard deviation is going to decrease just because of that. Yeah.
So when you say individuals, do you mean like the individual like dots?
Yes. Yeah. So I went from taking an individual dot to taking a mean of a sample of 3 dots. Yes. So what's actually on your sheet, and I'm coming back to this because I want to do something. It says averages are less variable and more normal than the actual individual observations. Well, that's what we just showed. My individual observations can get out here, but my means can only get out here. This is actually already printed on yours, I think. So looking at this, I've got a graph up here that is normal. Today we are only dealing with populations that are normal. Let's say I want to take a sample size of, I'll start with 5. And so it randomly picks me 5, and that's the mean that goes with that one sample. Could randomly pick another 5. That's the mean that goes with the sample. So this is the process that I'm dealing with. Here I selected 5 random. The only thing I actually record is the mean from that group. So now I'm going to do a couple more a little bit quicker. So there's another group, another 5 groups, another 5 groups, another 5 groups. And as I keep doing more and more, and this is only a sample size of 5, did it start out perfectly normal? No, it looked like it was kind of left skewed at first there. The more samples I'm taking, yeah, it's kind of starting to level out. What if I change my sample size to 25? I don't want to go through animating it. What happened? What do you see that's different about my, I can do both on here, mean. This one I'm going to do a mean of a sample size of 25, and here I'm going to do a sample size of 5. So that's 5 different samples. 5 of them are 25 up here. 5 of them are sample size of 5. What do you notice about those 2 graphs? But what is the same? So the shape is still fairly normal, but as my, which is something we've said before, as my something does something, as my sample size increases, my variability decreases. So it still just kind of justifies that point that we've been making all along. So the shape of the distribution of X bar depends on the shape of the population. So right now we're only dealing with ones that start out as normal. So if the population distribution is normal, this is where I hopefully changed yours because I don't like the way it's worded. Then the distribution of the sample mean is, what do I want you to write there other than is normal? Think about the one thing I've been very picky about with writing this down. Is it exactly normal? Approximately normal. And I think I put a blank back in there for you guys after I'd saved it and went back. And I think that's the only blank I added in up there, right? I didn't miss any ones above that. Oh, and then so here I see why y'all writing. This one I did add blanks in here. So averages are less variable and more normal than individual observations. That's going back for picking one dot versus picking three and writing down the mean. That was what I was doing with that graph. Trying to see how far I want to go with this video. Okay, so the very first problem underneath that, and you're probably going to need to either write on the back or write on notebook paper. You're not going to have enough room to do the rest on here. So the length of human pregnancies from conception to birth varies according to a normal distribution, or to a distribution that is approximately normal, with a mean of 266 days and a standard deviation of 16 days. You should get in the habit of writing things as you read. So I would come through here, and now I'm going to do highlighter just so you can see it, but pencil circling it is fine. What's the first thing I should probably circle and be like, that was really important? It went ahead and told me that. I need to know that. So circling that as you go is very helpful. Otherwise, you have to go back and read it again. As I continue on, this is how I do things. I do this. What symbol should I connect with that? Mu or X bar? Because that's the entire population. And this is my what? What symbol? So you need to get in the habit of writing things as you read. Otherwise, you're going to have to read it once, figure out what to do, and then read it again. If you get in the habit of doing that as you go, you're going to save yourself a lot of time and not miss stuff. So now it wants us to find a probability that a randomly chosen woman has a pregnancy that lasts for more than 270 days. Some of you right now are going to be very confused on how to do part A because of what I just did in the notes. But what we just did in part A, you could have done 3 chapters ago. So I want to find a probability. What am I finding the probability of? Tell me what to write right here. And that has absolutely nothing with what we're doing this chapter. That is correct. Why does that have nothing to do with what we're doing this chapter? What is that? One individual value, one dot, one individual. That has nothing to do with a sampling distribution of X bar. So that's before this chapter. So we just do everything that we already know how to do. My first thing is what? Find the Z. What numbers do I plug in? And it's a Z, so I want to round it to how many decimals? 2, and that gives me what? So I change this to a Z. What else do I need to do? And then 0.25 is on the right side. Which direction do I shade? To the right, because it's greater than. What do I need from my sheet? And the area for Z equals 0.25 is what? Is that my answer? And why should I look at my picture and know that that's wrong? I've shaded less than half, and that number is more than half. Remember, you're looking for stuff like that to catch your mistakes. So you're all right by telling me I was supposed to subtract from 1 because it's shaded to the right, and that gives me what? Did I write that right? 4013. So this is the probability of an individual being somewhere on that distribution. That is not saying the probability that our sample is here on the distribution of samples. You see the difference there. What does this problem, well, I'll connect that part later. So now I'm actually going to go step by step. So suppose we chose a simple random sample of 6 pregnant women. Well, that gave me something new. What is this? Lowercase n. SRS, we come back to this later, but the fact that it's random is going to be important. Let X bar be the mean pregnancy length for the sample, so it's already defining that for us. So what is the mean of the sampling distribution of X bar? You should be able to write this whole answer out by yourself correctly right now. What do I start with? Equals, which equals and you need days. What do I write for? So C, just like I did last time, I'm doing them step by step. So I'm saying, hey, what is this one? This is the thing that you would need to check to go with it. So if I were doing standard deviation sampling distribution, I would have sigma of X bar equals what? And what is my sigma? What is my lowercase n? Like 5 3s or something. I'm going to keep doing 4 decimals because people have been pretty consistent with that, and it's just easy to say the same thing. So that, again, literally that equation justifies the fact that as our blank does what, our what does what. As our sample size increases, our variability decreases. That equation literally tells us that. If we plug in a bigger number, we get a smaller number. All right, so check the conditions that are met. Use this formula. Come on. What condition do I need to check? And what is the 10% condition? Tell me what to write, like symbols wise. Which number do I know, capital N or lowercase n? Which is what? And so I need to say in words what's actually going on here, and there are at least what? And I'm just going with exact wording, but you're getting the same concept either way. Some people are going to change that wording up a little bit, like women who were pregnant women have people who have been pregnant, like you're getting the right concept there. I just usually go with the right wording. Yes.
For B, since it says like let X bar equal the mean pregnancy for the sample, why did you use the mean 266 if that's for the population?
Okay, so usually we do and define that, which is for all of them, and it did it like that and said for the sample. So like it did the same thing that we usually do. We usually start with the more generic one, which means the other one falls in it.
Okay.
They just happen to give it to us the other way because they're trying to, it's because it's the first day of notes and they're starting to do with X bar. And so they want you to know that X bar is technically what we're changing. But it's always going to be mu there. we don't know our X bar yet. So you won't get confused with that at this point. All right, now this is not on yours, but I want to kind of check it off to the side. Why could I go with this and do this one? Because it said approximately normal, but now I have samples. So the only time it is normal is when? Or so far that we've talked about today. So my sampling distribution of X bar is approximately normal if what? So I want to make sure that you understand we can use normal approximation because why? And you do not have to be specific here because technically we would have defined all this usually, and I don't want to mess you up. What did it tell us? Because the population distribution was approximately normal. I'm going to say because given that. And usually I just write given population distribution approximately normal, we can use normal approximation. So if it literally tells you, you don't have to do any math, you just have to write that connection right there. But if you just say given normal, so we can use normal approximation, I'll count off because we're given what's normal. I do need to see the connection that you understand that it's the population distribution that's normal. So I think a lot of you are getting mixed up with some like specific wording, which is good that I know this because y'all are asking questions about it. The sampling distribution of X bar is a distribution of all the possible dots for the X bars. So what is the population distribution? All of the dots of what? Of the what? So sampling distribution is dots for means. The population distribution is like all of the individuals. The dots for all the individuals, basically. So just making sure that you're getting those connections. All right, so now that we know that it's normal, we know what our mean is, we know what our standard deviation is, we know we can use our standard deviation. So how do I know, what do I see in this problem right here that makes me know that this is different than part A? So it's the mean of the group. I want to know the probability that the mean of the group is that. So I'm still finding the probability, so P parentheses. Am I still finding the probability of where X is? Now I'm finding the probability of where X bar is. And I still want greater than 270. So just so that we understand, these mean two very different things. This one is I picked one, I want that one person to be bigger than there. Here is I took a sample, I want the mean of that entire sample to be above there. So this is what we're moving to today. So now I've got all my information, so I can go ahead, what do I need to plug in to Z? And so originally, what was our equation for Z equals like the very first time we ever learned it? So I have switched this to just be very generic, and we are dealing with the value minus the mean divided by standard deviation. And I'm not plugging stuff in on purpose because I would have to change this to be sigma of X bar, sigma of P hat, or sigma. I'd have to change this to be mu of X bar, mu of P hat. And this might be p hat, it might be x bar, it might be x. So if we just think about it like this, you don't have to like memorize all the ones individually. So what is our, I like to go backwards here. What is our standard deviation for this problem? 6.532, we already found that. All right, what is the mean of that group, or the mean of that whole distribution? So those come from part A and part B. Now, what do I want to compare to that? $270. Well, my last value, before we even use a calculator, when I did it for an individual, I got a z-score of 0.25. Well, 270 is still there. 266 is still there. I've switched this. So now what is it going to be compared to 0.25? Higher or lower? Higher, because we're dividing by a smaller number. And you get what? And how many decimals do we go to for z? Everybody with me right now? Questions with me to get to this point? So rewriting this in terms of z. Draw a shade. Shade to the right. Find my area. What is my area for 0.61 for a z value of 0.61? Is that what I want? No, and this is more than half, that's less than half, so I do 1 minus, which leaves us with so my answer for part A was a little over 50%. My answer for part B, or for whatever letter we just did, D, was about 27%. Well, that should make sense because it ties back into here. The likelihood of getting something this direction, would that be easier if I was only picking one person or if I was picking a whole group of people? Which would be more likely, for one person to be that far away or a group's average to be that far away? Just one person. So the probability of getting something that far away should be more for a person than it is for a whole group's average to be up there. I don't want to deal with E right now. E does the same thing, but just finds us different Z values for different numbers. I feel okay with that. I want you to start doing B on the top right paper. So there's an A. For part A, I want you to write P parentheses and just do that part. And then I want you to actually start. It's like, I just want this part written for part A. And then I want you to start solving what you need to for part B.